Good afternoon, good morning, good evening, wherever you are in the world. Thank you for joining us here at Microsoft Build. Today we're going to go over some of the latest product innovations in Azure Compute. My name is Aaron Blasius, and I am joined by my colleague Varun Shandilaya. We are in the Azure Compute team and are here to talk to you about some of the innovations that we have in new virtual machines, I/O, as well as VMSS and our scaling technologies. We will be doing this presentation. I think we have 2 demos. We've got about 40 minutes of time to go over content, and then we're going to save some time for Q&A. Did you get that right? So we're going to talk about why hyperscale is important. That should be self-evident, but just in case. Optimizing price performance with the latest technologies, building for reliable speed, and easily scaling your applications and additional resources and sessions and Q&A. And like I said, there's a QR code that can get you to some of the previews and some of the other things that we're talking about today. But first, cloud providers must be able to support hyperscale applications, period. This is, of course, like I said, so self-evident, but what we considered hyperscale even just 2 years ago has been supercharged by AI. The demand is real when it comes to IOPS, power, performance. Every aspect of what we do requires greater agility and greater efficiency, greater innovation across the board. And we believe that Azure is best positioned to meet that demand. We understand that our customers need the ability to scale for basically all of the things that make us make our customers globally available, as well as just the interactions in our day-to-day lives. Azure drives all of these things, right? Whether you're using cloud for your business or in your personal life, hyperscale is a part of the interactions that we have, from just regular day-to-day purchases to driving business innovations. And as we innovate in our hyperscale application at Azure, we also understand that we need to be able to have high availability as well. So our global footprint and how we utilize power, how we utilize space, how we build, how we grow sustainably is also something that we are considering every day. Now, the greatest challenges when it comes to deploying hyperscale solutions are ensuring that you have high throughput, low latency connectivity between your application sets, and you make sure that the underlying compute resources meet the needs at the optimal pricing. Perf per dollar is a critical aspect of everything that we do, because the cost of the VM is not actually what a lot of our customers look at. It is the cost of the workload, right? What does it take to run the workload across a global footprint? Dynamically scaling a variety of compute instances and storage is also critical, because what good is it if I'm just spinning up one VM, usually in hyperscale, right? It's like, how do I deploy, manage, scale up and down for peak demand, because I don't want to run my applications if I don't need them, don't need my VMs on. I need to be able to have them scale so that they can meet our user base's needs. In this session, we'll go over the various ways that Azure is innovating to address these challenges. In this section, the first section we'll go over is the foundations of our virtual machines and how we're optimizing in perf per dollar. Now, this is the VM landscape. The broad portfolio of virtual machines that Azure supports, deploys today to meet a broad range of applications, everything from test and dev, general purpose, to the most demanding high-performance computing and AI workloads. But as with anything else related to cloud and being able to meet our customers where they're going, innovation is the key. And at Azure, we continue to invest to bring new products to market. And I'm proud, on behalf of the Azure team and our partners, to introduce the latest VMs available in Azure, enabling some of the most demanding hyperscale applications and performance-dependent workloads. This, of course, includes Cobalt 100, which you have heard Satya and others speak about here at Build. This is the underlying processor that supports and is the latest addition to our portfolio. It will be serving the DPS v6 and EPS v6 VM series, and we will talk more about Cobalt 100 soon. But these ARM-based VMs are only part of our portfolio. In addition to Cobalt, we are excited to announce new Intel and AMD-based v6 versions designed to meet and scale to the performance goals for our next generation of general-purpose compute, memory-intensive and compute-intensive workloads. Last November at Ignite, I had the privilege of being part of the announcement that brought Cobalt to market, that announced it as our first generation in-house custom-built ARM-based processor. And today I'm also excited because I get to announce the preview of it. We are deploying Cobalt 100 ARM-based virtual machines available for public preview in 7 Azure regions. These general-purpose and memory-intensive VMs are well-suited to run scale-out workloads and cloud-native workloads and offer the best perf per dollar in the Azure portfolio. These new Cobalt VMs offer 1.4x compute CPU performance and 1.5 performance on Java-based workloads, as well as double the performance on web servers, .NET, and in-memory cache applications compared to previous generations. Cobalt-backed VMs deliver up to 4x local storage IOPS and are even more power efficient than the previous generation. I could read this link out to you, but I won't. Probably be easier to just scan the QR code to get more information on the preview. And I will now pause to let you do that, should you feel like you don't want to miss anything. Also, it gives me a chance to do. Okay. But with the, starting with general purpose DPL v6 provides 2 gigabytes of RAM per vCPU, up to 96 vCPUs and 192 gigabytes of RAMs. And these VMs are designed for memory-efficient workloads such as media encoding, small-sized databases, microservice-based applications. These memory-optimized EPv6 series comes with 8 gigs of RAM per vCPU and offers 96 vCPUs and 672 gigabytes of RAMs, designed for large databases and data analytics workloads. One of the interesting things about standing up in front of all of these people is I have to make sure that the specs are actually correct. So like if I do, and some of these things don't exactly roll off the tongue. So I'm going to give everybody a minute to just take a look and understand that Cobalt VMs are built for our entire spectrum of general purpose workloads. This is, again, Cobalt 100 is our first generation of this. We are already working on, of course, the roadmap, which we will be excited to share in the future. But our goal is to make sure that we cover every aspect of general purpose, from the small memory to vCPU ratios to the largest ones, and we will continue to expand this portfolio. We also are, the all-new Cobalt v6 VMs offer, wow, that's a mouthful. I'm not going to say that right there. But we're moving local SSD, temporary storage options, as well as a range of remote storage options from standard state and hard state drives, premium, ultra, local SSD. Now, we've been working closely with our with a few select design customers to bring these products to market because we had to make sure that they were ready for prime time when we introduced this preview to the rest of the world. Customers such as Anis, Elastic, MongoDB, Siemens, Snowflake, and Teradata are all looking forward to the effectively scaling their compute footprint with new VMs while achieving greater performance. And to showcase what our partners are helping us bring to market, we're now going to give you all a demo and a preview of cloud-native workloads on AKS and the improvements that you can see with Cobalt 100 compared to the previous generation.
I'll demonstrate how to update an existing microservices application built around React and Node.js for ARM64-based virtual machines. Then, I'll show how our newest ARM-based version 6 SKU using our Cobalt 100 processor improves performance compared to our previous version 5 SKU in a side-by-side test. To get started, I'll use the to-do application sample from the official Azure Samples GitHub repository. This application uses multiple Azure services like Cosmos DB, Azure Container Registry, Azure Monitor, Azure Key Vault, and Azure Kubernetes Service, which hosts the version 5 and version 6 Cobalt node pools running the React and Node.js workloads. First, I need to make changes to some of the code to build this application for the ARM64 architecture. I need to ensure the right architecture is used when pulling the Docker images by defining the platform as part of the image pull. In the existing bicep code, I'll add the node pool that represents the version 5 and version 6 ARM64 SKUs. I'll define them using the exact same 4-core 16 GB of memory for the side-by-side tests later. Then, in the main bicep file, I'll add the new SKU options as allowed parameters. And last, I'll ensure we pass the parameter as an environment variable to the agent pool where the workload will run. Our code changes are now done. From the root of the repository, in my local build environment, I'll use the command azdup in the Azure Developer CLI to deploy the infrastructure, build and package our Docker image, and deploy to AKS. I've already pre-provisioned this environment, so I'll jump over to that to compare our version 5 and Cobalt to-do application. Here are our applications side by side, one running on our version 5 nodes and the other on our version 6 Cobalt nodes. The application is identical because we've made no changes to the code, so I'll go straight into performance testing. To do so, I'll use Azure Load Testing, a fully managed service that allows you to simulate high-scale traffic for your applications. I've already created 2 tests to load the React frontend by fetching the index as well as test responsiveness of the Node.js REST API. After running the test over an hour period, you see the version 5 results on the left and the version 6 Cobalt results on the right. Looking at the comparison, the version 5 nodes managed 8.69 thousand requests per second compared to the Cobalt series, which achieved 11.9 thousand requests. Amazing. That is using the exact same core and memory configuration, yet represents an increase of 37% compared to our version 5 nodes. Not only that, but the version 6 Cobalt series response time was 15% lower than the version 5 environment. I was able to take an existing application and quickly port it to our ARM-based VMs. Then, using our latest version 6 Cobalt 100 SKUs, I was able to achieve higher performance and lower latency compared to the previous generation version 5 SKUs with no additional optimization or code changes.
Amazing. Now, in addition to the Cobalt VMs, we are excited to announce the latest 6th generation of Intel and AMD series VMs. Our partnership with Intel and AMD goes back decades, and we continue to work closely with these industry leaders to deliver the latest advances in processor architecture and ensure that our customers have the ability to choose the VM that best fits their workload. These VMs mark improvements across the spectrum: superior price performance, throughput, remote and local storage IOPS, and bandwidth, ensuring developers can create applications no matter their performance requirements or architectural optimizations. But the CPU isn't is only just part of the performance picture. At Ignite last November, we also announced Azure Boost, which is part of the underlying architecture that delivers speed and throughput for networking and storage. Boost offloads I/O virtualization processes traditionally performed by hypervisor and host operating systems onto a purpose-built hardware and software stack. Developers running their applications on Azure VMs backed by Boost will be able to take advantage of class-leading network and storage performance with improved throughput, IOPS, latency, and jitter when compared to our older VM sizes. Our latest V6 VMs take advantage of Boost innovations, providing up to 200 gigs of network throughput and 12.5 gigabytes per second of storage throughput. Our V6 VMs are also the first to have our new in-house network interface Microsoft Azure Adapter, or MANA. We've worked closely with both our Linux distro partners as well as our virtual appliance partners to integrate this new NIC using Azure Boost, and MANA will provide, let me start that over. Using Azure Boost and MANA will provide developers the means to accelerate their workloads through features such as SRIOV and DPDK. Now, I've been able to talk to you a little bit about the foundational infrastructure of Azure Compute. And now I'd like to turn it over, and like to thank you for your time, and turn it over to Varun, who will tell you how to scale these new innovations and new VMs. Varun?
Thank you, Aaron. Oh, awesome. That was very precise of transition. My name is Varun. I will talk about how do we use this awesome capabilities in VMs and how, as a developer, you can deploy them, manage them, and scale them, and what it means from that standpoint. One of the big problems that customers face when they are running their workloads is not just provisioning of the VMs, but how do they get their workloads or applications on the VM at the right time, so that when a scale out event happens, you are able to scale out and get the traffic on it. Generally what happens is you will say, I want to scale out by 10 VMs, we will give you the VMs, and then you will do some initialization on that, and then that takes time, and by the time the peak has gone off and you're like, well, I needed more VMs for that. To address that, we are bringing a capability in virtual machine scale sets, which is called standby pools. What standby pools do is they reduce the latency by providing you VMs that you can pre-configure and have them in a standby mode within virtual machine scale sets, and then when a peak comes in and when you scale out demands require you to add more VMs, you can get the VMs from the pool which are completely configured, and you swap them into your scale sets and start taking traffic. So that reduces the latency. It gives you a place where you can initialize your applications. If you have to download data, you can all do that. On the right, if you look at the scale numbers, you can see, like, for scaling out 50 VMs, you can do in less than a second. And then for 50 VMs, you can do under like 40 seconds. But when you run the standby pool, the VMs that are running are charged, so you're paying for that. To address the cost aspect of it, we've also introduced an ability where you can deallocate or stop the VMs. You can configure the VMs, and then you can stop the VMs and have them available in the pool. And when you start those VMs, or when you need those VMs, you will start them and basically put them in the pool, in the scale set. This is how it kind of works. So in scale sets, you have two traditional paths. Either you can scale out, or you can create a standby pool, and in that standby pool, you can have running VMs, or you can have stopped VMs. And when your scale set demands more VMs, if they're in the deallocated state, we will start those VMs implicitly. You don't have to do any action. You just issue a scale out. We'll start those VMs, and we'll put them into the scale set, and you can start taking traffic. So this basically helps a lot of workloads which require downloading data from the cloud, or configurations, or joining some network or whatnot. So that reduces that latency time out. To showcase this, I have a demo.
for virtual machine scale sets allows you to use a pool of pre-provisioned virtual machines to quickly scale out, saving you time by performing initialization steps like installing applications and software or loading large amounts of data. To create a standby pool, go to the Standby Pool blade and select Manage Pool. Then, name the pool, select a power state, and how many instances we want. Azure will now begin creating the virtual machines and completing all post-provisioning steps. Now that the instances are ready in the pool, I'll start a scale-out event. To do that, I'll change the scale set instance count from 0 to 10. Then, over on the Instances blade, I see the instances have been moved from the pool into the scale set. These are the 10 instances that were originally in the pool, now in the scale set. If I go back to the Standby Pool blade, I see that all the instances were moved. Now, when I go back to the Scaling blade and change the scale set instance count to 5, I'll see the Standby Pool begin to fill to maintain the maximum capacity I configured during the pool creation. The Standby Pool now has 5 instances in the pool, and the scale set has 5. Any further scale-out events will once again use instances from the pool. By using Standby Pools, you can respond to scale-out events much faster than before, even at significantly greater scales.
Awesome. So standby pools and scale set use the same capacity number, and then you can shift VMs from one to the other. And we're going to be working more on standby pools and how we can further help you reduce the cost of having these VMs running in the pool itself. So look out for that as we go along on this journey. Let's talk about virtual machine scale sets, or VMSS. So VMSS, for folks who don't know this, provides you the ability to deploy VMs at a large scale, have availability guarantees, and by availability guarantees across different zones or different fault domains. Some of the primary things that we focus on from scale set is availability resiliency, scale, security, and operational agility. So to talk about that, from a resiliency standpoint, there are a lot of scenarios in which you would deploy your application and the application fails for a certain reason. It could be a failure in the application, or there is something happening in the VM because of which it's not able to connect to the network and whatnot. We have a feature of application instance health replace in scale sets, which would monitor the health of the VM, and if it identifies that the VM is unhealthy, it would go delete it. We heard a lot of feedback from the customers where like delete is a very invasive operation. Rather than deleting the VM and recreating a new one, we need more options, and that's where we introduced reimage and restart as an action, where instead of deleting the VM, you could reimage the VM, you don't lose that capacity, and you can just reimage that, or you can just restart the VM, and you can set those policy at the scale set level, and then when those actions happen, we would take that action. And it's generally available in June of 2024. The other enhancement which comes to scale, a lot of customers who don't start from like, large application, thousands of VMs, they're doing like proof of concept. Think of like a mom and pop shop. They have like, 1 or 2 VMs, they're trying something, and suddenly now you have to scale out because, someone tweeted about that business and now you have like a lot of online orders coming in. Before this, you would have to kind of go create a new scale set or like figure out a scaling strategy of how you're going to scale out and whatnot. With the ability of attaching and detaching a VM to a scale set, now you can take that existing VM that you have in your subscription, and you can attach it to an existing scale set without any downtime. And then from there on, you can provide scale set a scaling profile. You can say, this is the shape of the VM, the VMs that Aaron kind of talked about. This is the image that I want, the operating system, and these are the applications that I want. And then from there on, you can provide scaling rules, and it will scale it from there on. So this is also going to be generally available in June. From a security standpoint, for Linux customers and customers who are deploying applications on Linux, getting security patches was a very tedious or unpredictable aspect. So we've worked very closely with Canonical, and we've released the strict SDPs. SDP stands for Safe Deployment Practice, in which we will do the snapshots of the packages that Canonical or Ubuntu is going to publish, and we will go region by region, zone by zone, and in batches, and update the VMs with the patches that are provided for them. So that helps you to be secure and also be confident that you have the right patches and you're not going to have any availability hits as part of that. Lastly, from an operational agility standpoint, Azure is working through enabling customers to deploy in availability zones. Availability zones are constructs in our region which have a physical distance between them, and that provides availability guarantees across them. A lot of customers today have deployed their applications or their workloads in a regional fashion, and they're all kind of looking for ways to move or migrate their workloads in a zonal resiliency fashion. So we've added capabilities in ScaleSat where you can update your existing ScaleSat, which is a regional deployment, and then you can provide the zones that you want to scale or distribute your VMs into. And then any further scale outs that happen from there would happen on the zonal boundary. So if you add 3 zones and you add 3 VMs, 1 VM will kind of go in each of the zones. And then when you scale your deployments back in, we will scale down the old VMs which do not comply to the ScaleSat model. So you have better operational agility, you don't have to have a downtime, you can just scale out and scale in, and your customers don't get any inability to work with your applications, right? And then you just, over time, move to a zonal construct and have higher availability SLAs for your workloads. When it comes to scale, it becomes very hard for customers to manage a lot of VMs, right? Like you think about very large scale workloads which have thousands and thousands of VMs, and getting capacity or like identifying which is the right SKU that I need to use or which VM is the right fit for me. And you might have 2 or 3 VMs which are very good fit for you. And how do you ensure that you are able to use the cloud to the extent it's possible? So for that, we are introducing Azure Compute Fleet. It's a new product and service that we are launching in preview today, which enables you to provision thousands of VMs with a single API call in a region. And you can define the configuration for these VMs that you want, and you can apply different VM SKUs. All the VM SKUs that Aaron kind of just talked about, you can have a list of VM SKUs that are defined within the profile of the fleet, and we, Azure, take the responsibility of giving you the capacity that you desire using the list of SKUs that you've provided. It also offers different pricing strategies. You can use standard and spot VMs. Spot VMs, for those who don't know about spot VMs, these are our evictable VMs where we offer up to 90% discount on these VMs because they use our unused capacity, but we can reclaim these VMs back when we need capacity, and you get a 30-second notification for that. So it's a good way for you to scale out if you have interruptible workload or a resilient workload from that standpoint. It also helps with the hyperscale aspect where you can scale out, you can fire and forget, you want n number of VMs, you basically tell us what number of VMs you want, and then we look at the VMs and then we scale out from that standpoint. Just from an overview standpoint, we kind of covered most of it, but certain things to call out here is you can also maintain spot VM target capacity. This is one of the feedback that we got from customers because spot VMs can get evicted, and then you would not know if a spot VM is evicted, how many VMs did I deploy, and how do I get back my VM. So we will monitor any evictions, and then we'll reclaim that capacity back for you to get you back to the target capacity that you initially told us that you wanted to be at. So that helps us to ensure that you always have the capacity that you need, and we might use different SKUs for that. And we'll use the list of SKUs that you've already provided us from that standpoint. We did a test for one of our customer workloads using standard and spot VMs, and you can kind of see on the pie chart on your right, where it's basically using up to, I think, 6 or 7 SKUs to get the capacity of 10,000 VMs from deployment, right? So we deployed, I gave it these list of SKUs that I wanted. I can actually give up to 15 SKUs to this, but I use the SKUs which had the most amount of capacity or had less price. So you can, with Azure Fleet, you can have two optimizations that you can provide us. You can say, I want to optimize for price, or I want to optimize for capacity, or third, you can say, I want to optimize for price and capacity, and then based on that, whichever is the cheapest VM, we will give that VM to you. And then you can also specify what's the distribution of standard or on-demand VMs and spot VMs you need, and then we'll honor those as well. So you get more control, you can predefine them, and you can forget about it, and then we'll go deploy them. So that is like a huge capability that addresses the hyperscale needs and cost from a customer standpoint. We've been working with a lot of customers, and ExoStellar has been one of our pioneer customers who've been using Fleet, and they've been pretty excited about how they can drive AI-driven workloads and migration technology that they've built using Azure Compute Fleet to reduce the number of evictions that the customers will see. With that, we lied. We have 3 demos. So we under-promised, over-deliver from that standpoint. So I have a demo for Azure Compute Fleet and how that works. So I'll play that.
I'll demonstrate how to deploy Azure Compute Fleet, a fundamental component that enables the creation of a virtual machine fleet, combining standard and spot VM types via a single API call. I'll start by creating a compute fleet in the Azure portal. In the search bar, type Compute Fleet, and then select it on the Compute Fleet page. Select Create Compute Fleet. Start on the Basics tab. Under Project Details, select the subscription and resource group. In Instance Details, type the name of the fleet. Also, choose the region, availability zones, and security type. Then, choose a marketplace image and select your CPU architecture. Next, configure the virtual machine types. As I mentioned earlier, you can include both standard and spot VM instances in your fleet. Then, move on to selecting your VM sizes. You can select up to 15 sizes, which enhances the diversity of SKUs in your fleet and enables quicker access to Azure resources. The next step is to configure the spot VMs. Set capacity preferences to maintain capacity. This ensures that if a spot VM is evicted due to pricing or capacity issues, the fleet will automatically replace the evicted VM with an alternate VM size to maintain target capacity. You can also set your target capacity. Compute Fleet allows you to deploy up to 10,000 instances in a single request. Set the eviction policy next. Selecting Delete VMs removes the VM and all its resources. Selecting Deallocate VMs keeps the data, including the NICs, disk, and storage. Moving on to allocation strategy. Spot offers 3 different allocation strategies for different workload requirements. I recommend selecting Optimize Price and Capacity to balance costs with high availability. Next, you can set the hourly price for Spot to give you price protection in case spot prices increase during your fleet runtime. After that, configure the standard capacity of the fleet. Just specify the target capacity, and if you would like to specify the minimum starting capacity, you can do that too. And finally, configure the administrator account. So now, I'll go to the Networking tab by selecting Next. For my demo, I've already filled in this information. And with that, I'm ready to create the compute fleet. It can really be that simple. Just 2 tabs on the Create a Compute Fleet page. We tried to make it as easy as possible to launch multiple instances via a single API call. Just select Review and Create to start the validation process. Once the validation successfully passes, I can create the deployment by selecting Create to submit it. And now, deployment is underway. You see the fleet resources getting created and the VMs provisioned. This will take a few minutes. And now that deployment is complete and successful, I can go on to the Manage Experience page by selecting Go to Resource. Fleet level information is here, like the resource group, the successful provisioning status, and the subscription ID used to provision the resources. We also have the compute fleet details, which includes the region, the target capacity for standard VMs, the target capacity for spot VMs, and the disk level details, and the different VM sizes that were included as part of building this fleet. Now, move on to settings, under which are instances, capacity, and sizes. These offer more granular information about the VMs and their capacity. Select Instances to see all the VMs provisioned and their statuses. In this case, they're all running and successfully provisioned. It also shows whether the VMs are standard or spot, and the VM sizes used to meet the target capacity. You can always change target capacity at any time. For example, if you have excess capacity, delete as many VMs as necessary. Select individual VMs, standard and spot, and delete them. That's it for my demo. If you have workloads that are fault tolerant and can handle interruptions, Compute Fleet offers the best savings on cost while optimizing for capacity to complete your workload.
It is that simple. I like the enthusiasm of our demo guy. I hope you're also that enthusiastic about all the things that we're talking about. But we didn't just stop there. We know a lot of our customers use scale sets today. It is by far the default way almost all customers deploy infrastructure or compute infrastructure today. We've released Virtual Machine Scale Set Flex in the past, which gives you heterogeneous VMs. It's used by a lot of Kubernetes and Linux workloads today. And to maintain availability and for security and for scale. One of the big problems that we were kind of trying to address in that was how do we give this SKU diversity or heterogeneity to customers? You can do it today. You can add a single VM, which is like, AMD or Intel, if the scale set is an AMD scale set, and then you can add an Intel VM to that. And we started to see customers start to use that. And as we were building Fleet, we thought it would be good to bring the same capability into scale sets as well, so the customers can use that capability within VMSS Flex as well. VMSS Flex is a short form of Virtual Machine Scale Set Flexible Orchestration Mode. That's the full name of it, but we use VMSS Flex because I can use the whole hour or day if I keep saying that. With VMSS Flex Mix, you can specify up to 5 SKUs within that. It also gives you the cost optimization with Spot and On-Demand being together. It also will provide easier management from that standpoint, so you can tell the scale set and then you get all the capabilities of scale set, which is auto scaling, instance repair for all diverse VMs that get deployed within that set. From an overview standpoint, the major difference that, the main thing scale set provides or VMSS Flex provides in Fleet capabilities is it kind of brings in the intelligence of the fleet of like SKU diversification and what SKUs to deploy and whatnot, but also provides availability guarantees if you have fault domains or availability zones defined. And we will spread these VMs across different availability zones or fault domains. For people who do not know what fault domains are, these are our isolation units which prevent you from any host beta updates or any updates that we do on our infrastructure. And there is no extra cost. The cost that you pay for this, even in Fleet, I forgot to mention, the cost that you pay is the cost of the VM. The service by itself does not cost anything from that standpoint. I've got 6 minutes left, but I think I'll wrap up and have questions. So from a wrap standpoint, in the session, we've talked about the full life cycle and all the capabilities that you can use to deploy hyperscale infrastructure with the newer generation of Cobalt 100 VMs and Azure Boost capabilities. We've talked about Virtual Machine Scale Set, which is the deployment vehicle for you to get access to these VMs and use them, and a new way of deploying thousands, up to tens of thousands of VMs using Azure Compute Fleet. These are available in preview or GA based on the slides that I've talked about. So we would really like for you to go use them. If you want to learn more, Here are all the blogs. We don't have the QR codes for this, but we've tried to make the links simple for you to go and learn more about these offerings and products. And we have a partner session today. Has already happened. So if you missed it, sorry. But we should have talked about it before. That's it from us.
Available online.
It's available online. That's it from us. These are resources, and we've time for questions. So, Noah?
There we have a microphone so that people can online hear, and I think, Noah, you're going to have some other, you have some questions that came in online for us too.
Yeah, thanks, Aaron.
Whoa.
Is this loud? Not too loud.
There's a speaker right there. No, go for the question. Do you have a question?
Oh, yeah. So with the new Azure Cobalt VMs, I think one of the first questions our customer is going to ask is, are these going to support the Azure Compute Fleet as well, Varun?
Yes, any VMs which are either in preview or GA will be supported on Azure Compute Fleet or VMSS. It depends on the region that you're in. So, if the region has that Cobalt 100 VMs, you should be able to use any of our deployment technologies, Compute Fleet, to deploy them. Thank you.
Awesome. Feel free.
Amazing is the word of the day. Not awesome.
Thanks, Aaron.
Yeah. Go ahead. Yeah.
Can I request VMs on a specific host together? So if I request like 2 or 4 VMs, can I have them on the same host?
No, would you mind repeating the question into the microphone?
Sure thing,
Thank you.
Aaron. The question was, can I specifically choose to deploy multiple VMs on the same host? Is that correct?
So we have a product called Azure Dedicated Host. So you can buy the host itself, and then you can manage the VMs that you deploy on it. So you don't pay for the VMs in that case, you just pay for the dedicated host, but all the VMs that you deploy within that get deployed within that host. You can also ask for a host group, so that multiple host groups that are kind of combined together, and then you can manage that capacity by yourself.
Is it like a latency use case? Okay.
The other concept, like if you don't want to manage host and whatnot, we also have proximity placement group, which puts you on the same T2 network spine. That also has very low latency, and that guarantees you that the VMs that are going to be deployed are going to be on the same network spine for you to use them. Those would be the two constructs that I would kind of suggest to address latency.
Yeah, we have another.
Yeah, you might-
Go ahead. All right, so go first, I'm sorry, over there.
I have 2 questions.
Sure.
What kind of unique have?
Noah, can you help us out with the microphone, please? We can go over and also let him ask the question so that everyone online can hear it. Posterity and all.
So my first question is regarding to the NIC type of that particular VM that is available in Azure. And the second question is, can a user request a certain NIC type in Azure?
NIC type. Well, so Boost, I think you were basically asking like, how do I determine what the I/O interface is on the host?
Yes.
Yes, that's actually done by VM type. So each generation of host has its own NIC. So you're basically into Boost, the next generation of Boost for V6. So you'll have a certain characteristic. So if you get a V6 Boost or a V6 VM, you will have the generation and the I/O capabilities that are associated with that. The further back that you go, the less capable the VMs, because it'll land on that version of hardware. Well, actually, it's limited to that particular I/O set and capabilities. So, like for example, it is possible that you can have a V4 land on either the shipping generation of V4 or a newer generation, but you will be limited to that capability just because you want to make sure that the VM hardware profile matches what the expected is. So we do that through virtualization.
Okay, thanks.
Yep.
So I have two questions. First question is, can we create VMs using a custom image on Azure Compute Fleet? And the second question is, before I use the VM for the production use, can I change VM from a Spot to a standard VM?
So for the first question, yes, you can use a custom image. So we have a service called Image Gallery, Compute Image Gallery, I believe was the rebranded name. Azure Compute Gallery, thank you, Noah. So you can create a custom image, and we recommend that you use that image gallery to upload that image, because then what we can do is we can replicate that into different replicas, and when you're doing a scale-out operation, you're using different replicas to create your VMs, right? So you can absolutely do that. And then it also offers the capability that you can have newer versions, and you can do multi-region with that, right? Like you can have snapshot of the same, you can define like these are the regions that I want, and which version is in what region, and like which version you want to use to create your VM. So you can absolutely do that for sure. The second one, the answer is no, for converting a Spot VM into on-demand VM. And the reason is, we want you to build your workload in a way that you can either be resilient, so that like if infrastructure kind of goes away, you can have it back, and also use on-demand VMs. But how you kind of solve that problem is within Virtual Machine Scale Set and Compute Fleet, you can have a mix of both on-demand and Spot together, right? So you can scale out, and then you can keep monitoring, and we'll add more features to Compute Fleet and how you can monitor and distribute your VMs across that.
No, the red light and the flashing dots are telling me that we have to wrap up on stage, but we will be over here with our colleagues to answer questions offline. Again, thank you all for joining us today, and we encourage you to again check out the previews and enjoy the rest of your afternoon, evening, or morning, wherever you may be. Thank you very much.
Thank you.
If you have any questions, experts will stay up at the front.